Let's start.
Okay. Wonderful.
There we go.
Okay, great. My name is Elinor McGrath. I'm a fisheries biologist with the Okanagan Nation Alliance, and welcome to our webinar about watershed drought and salmon survival. So I'll go through my presentation first, and then I'll pass it over to Eva, who has a couple more slides, I believe, about water conservation, and then we'll do questions after that. Okay. So, although most of us are probably familiar with the Okanagan watershed, I'll start with that. So this is a map of the Okanagan watershed and the siwڵkw, and it is showing Okanagan and Syilx lakes and skৱ் lakes in the middle of the valley there. So water in this watershed flows from north to south, all the way from the headwaters up in Okanagan Lake toward skৱ් Lake down by Penticton. That's very small, you can barely see it. And then to Syilx Lake, and then across the border into the United States, and eventually into the Columbia River in near Brewster, Washington. And then the Columbia River flows all the way down to Portland, Oregon, and empties into the Pacific Ocean there. The map also shows the siwڵkw, and I'll talk a little bit more about that later on. And then, of course, there are adjacent watershed in Syilx Territory, including the Nicola, the Salmon River and Bassett to the north, the Kettle, and the Upper Columbia River to the east. So today I'll talk mostly about the Okanagan watershed because the effects of drought on salmon are just very pronounced in this watershed. But many of the observations I'll talk about today do apply to salmon and trout in other watersheds as well. Okay, and I'll say something else that I think most of us are aware of. The Okanagan is a very nice place to live, and our population has been increasing rapidly because people are moving here. So as a result, there's been a lot of construction of apartment buildings and houses, and more people moving here and needing water. It's also a key area for agricultural production, and people here also really seem to like to play golf. So all of this has resulted in an increasingly intense competition between water consumption and ecosystem needs. So even before we began seeing the more recent frequent droughts as a baseline, there was already a strong competition between human and ecosystem water needs, and this is now being exacerbated by changes that are occurring in the climate. The Okanagan is naturally a semi-arid region with little precipitation, especially in the summer months. Our salmon have evolved under a snowmelt-driven hydrograph with peak flows in May and June. Those are driven by snowmelt and also typically some rains we get in the spring, and then followed by a decline in flows with relatively low flows in the summer and in the early fall. Over the last few decades, due to a trend of warming air temperatures, there's been a shift in the timing of the snowmelt to occur earlier than normal. So the blue line here shows the historic timing of the snowmelt, peaking around sort of the middle of May to early June. And now in recent time, we're seeing a shift to earlier and earlier snowmelt by, probably 1 to 2 weeks or even a little bit more. So this is leading to a longer periods of summer low flows. You can see the hydrograph drops earlier, and there's just a longer time that we have those really low stream flows that are typical in the Okanagan through the summer. This trend is unfortunately expected to continue in the future and result in even earlier peak flows, as well as a larger portion of the precipitation falling as rain in the winter instead of snow. So that has as a consequence that we lose all that free water storage in the headwaters that normally occurs in the form of snow. And we're also losing the cold water snowmelt inputs into our rivers in the spring and early summer that are so important to our salmon. So with the trend of higher air temperatures, water temperatures have also increased and are projected to increase further in the future. So with the warmer air temperatures, we're seeing warmer water temperatures, and that's really not good for salmon because they're cold water fish and their metabolism works best at cooler temperatures. Add to that drought. So the term drought means at the most basic level that conditions are abnormally dry relative to historic conditions. That means often low precipitation, low stream flows, low groundwater levels in our aquifers, low lake levels, as well as low soil moisture. So on top of this longer term trend of warming air temperatures and earlier snowmelt that I talked about in the prior slide, the Okanagan has experienced drought conditions much more frequently in the last decade than in the decades before that. From the 70s onwards, we used to see maybe 1 to 3 drought years per decade. But in the last 10 years, almost all years have had some sort of elevation in drought level. So it's becoming much more frequent. And we are currently going on, I believe, year 5 or 6 of back-to-back droughts starting in 2021. So it's become almost the norm rather than the exception. Another important term that I want to mention is water scarcity. So water scarcity means that there is not enough water to meet both human needs and ecosystem needs. And water scarcity can happen with or without drought, but drought tends to make water scarcity a lot more severe and really intensifies that existing conflict over water use. So the next few slides, I'll talk about the effects of drought specifically on salmon. And I'll start with the figure about the salmon life cycle. From egg deposition in our streams in the fall to the salmon hatching as alevins in the late winter, early spring, and then emerging from the gravel and turning into fry in the spring, growing bigger to par stage in the spring and summer, and then eventually turning into smolts and migrating out to the ocean. After a few years at sea, the salmon will return as adults and migrate back up the Columbia River and then the Okanagan River back to their natal streams to spawn. There are 3 key ways that drought affects salmon. One is by reduced flows, which translates to less wetted space and often slower water velocities. It really just reduces the amount of habitat that's available. If you compared it to humans, you could compare it to living in a 500 square foot cabin to a 5,000 square foot house. There's just less room for them. The second is high water temperatures. High water temperatures often go hand in hand with low stream flows. And during droughts, there tends to be a lack of cold snowmelt water, there tends to be hot and dry weather, and that all increases stream temperatures, and those are not good for salmon. And then third, there also tends to be an effect on water quality. Warm water can really favor excess algae growth, resulting in low dissolved oxygen in the water, as well as harmful bacterial blooms. So now I'll take us through the life cycle of a salmon and how drought affects them at different life stages. I'll start with alevins and eggs. So in the fall, salmon lay their eggs into nests in the gravel of streams or rivers called redds. On the bottom right here, you can see a nice picture of a red that was dug in one of our local streams here. It's the light colored gravel in the center there. So salmon often pick locations in the streams that have a good flow of water through those gravel spaces that the eggs and alevins lay in. So the top right picture here, you can see the red little alevin that are laying in between the interstitial spaces in the gravel. And it's important to have a good flow through that gravel to deliver dissolved oxygen to the eggs and alevin and also remove waste. Drought conditions can cause very, very low flows in the winter, and that can de-water redds altogether or expose the alevin in the gravel to air and freezing temperatures. Also, with the lower flows, we tend to get decreased water velocities, so that can reduce the amount of water flowing through the gravel and delivering that oxygen and removing the waste from the alevins. So that tends to have a negative effect on them. In addition, when the flows are really low and gets cold, there can be really extensive ice formation in the streams, and sometimes it reaches all the way from the water surface to the stream bed. And that ice can block the flow of oxygenated water into the red, or it can even freeze the eggs and alevins altogether if the ice extends into the stream bed, and that causes mortality. Okay, on to fry and par. So the alevin have now hatched and have come out of the gravel or are in their natal streams to rear. So we have 2 types of juvenile salmon behavior in the Okanagan. We have some salmon that rear in their streams, in their natal streams that they were born in. or in other areas. And then we have some that migrate directly into the lake and utilize the lakes for rearing. So I'll start with the stream rearing types. So when drought occurs, there tends to be reduced flow during the spring and summer, and that just results in less available rearing space for the fry and parr in streams, like I mentioned before. So there's just less room for them. In addition, the lower flow also typically comes with lower water velocities, and that reduces the amount of insect drift from riffles. So the juveniles tend to station themselves downstream of riffles, and they feed on insects that drift down in that fast current coming out of the riffle. So if the current gets really low, then there's less insect drifts and the fish have less food available to them. Salmon also require cold water, and when the stream flows get very hot, the water gets quite warm typically. The high water temperatures increase metabolic stress on the juvenile salmon, and they also tend to result in reduced dissolved oxygen in the water. So if temperatures get too hot, they can be lethal to juvenile salmon, and then there's a mortality event. When flows drop really low, like you can see in some of these pictures here, the surface connection between fish habitats like pools and glides can become dry. And that leads to juveniles being stranded in these disconnected pools or side channels with no way out until the flows increase again. In those disconnected pools, dissolved oxygen tends to deplete fairly quickly because the areas don't receive river water flowing in. And there tends to be a lot of juvenile concentrated in those areas, and that results in fish kills. On the bottom right here, you can see a juvenile rainbow trout that was exactly in that kind of situation and unfortunately died as a result. And as an absolute worst case, the stream becomes entirely dewatered and all of the fish die. The bottom left picture is not a walking path, even though it kind of looks like that. It is actually a dry stream bed in one of our local rivers here. Okay, now I'll talk about the juvenile salmon that rear in lakes. So sockeye salmon and a portion of Chinook salmon juveniles in our area rear for up to a year or two in the large lakes in our valley bottoms. So that's Syilx, and Okanagan lakes. The picture at the bottom here shows a cross section of a Syilx lake from north. So on the left-hand side is the north end of a Syilx lake. That's where the Okanagan River flows into the lake. And then to south, which is on the right-hand side, that's the outflow that flows into the US and down to the Columbia River. When the water warms up in the spring, the surface layer of the lakes gets warm, and then the lakes thermally stratify. So that creates distinct layers in the lake with different water temperatures, and there's actually very little mixing between those layers until later in the fall, when the surface becomes cool again and the whole lake turns over and mixes again. So in the summer, the surface layers of our lakes become too warm for salmon. So they have to go down to depths to find cooler water. So you can see the little baby salmon here in this little white space. That's the usable volume of the lake for salmon. At the same time, though, the oxygen in the lower levels of the lake becomes depleted because there's no mixing with the upper layer that receives oxygen at the air-water interface. This phenomenon is especially pronounced in the Syilx Lake, which tends to be quite shallow, has a lot of nutrients, and gets very hot at the surface. So as a result of this, the bottom of the lake also becomes unusable for salmon as the oxygen gets depleted, and they become squeezed into a layer in between the high temperatures at the top and the low oxygen at the bottom. So that's this usable volume here in the white space. In the north basin of a Syilx Lake, that layer varies from year to year, and sometimes those two layers meet. And when that happens, we get very poor juvenile survival for that cohort of fry rearing in the lake because they tend to die. In the central and south basin of the lake, those layers meet every year. So it's an annual occurrence, usually beginning sometime around mid to late June. So we don't usually tend to get a lot of juvenile sockeye rearing in those areas because the habitat becomes unsuitable for a large portion of the year. During drought, the weather tends to be drier and hotter than normal. So the setup of stratification begins earlier in the spring and leads to a longer period during which the salmon are squeezed into this layer of reduced usable volume. In addition, flow from the Okanagan River that flows into the north end of the lake here supplies some oxygen to the north basin of the Syilx Lake. And if the flow is lower, then there's also less oxygen that is supplied to the lake. So these all can combine to have a negative effect on rearing conditions in the Syilx Lake. Okay, on to the smolts. So salmon smolts are the life stage when they begin and complete their migration to the ocean. So they tend to smolt during the spring, and they time their migration to the ocean with freshet flows. Fast water makes it much easier for them to travel, so they have to spend less energy actively swimming. But during droughts, freshet flows are typically much lower because of a lower snowpack and less rain, and water flows much more slowly. So it takes a lot longer for smolts to make the migration, and they have to spend more energy getting from A to B because they have to actively swim instead of just drifting with the current. Typically, freshet flows also tend to be quite turbid. So brown water, like on the bottom left here in the picture. This also happens when we get a lot of rain events, and that's actually good for salmon because it provides great cover from predators because they can't see them. When freshets are lower, especially in the absence of spring rains, the water tends to be less turbid, so the water is clear and the smolts can't hide as easily from bird and fish predators. So it's much easier for those to pick off the smolts as they migrate along because they tend to migrate on the water surface. So they're quite visible when the water is not turbid. There are also some concerns around the conditions in the Syilx Lake. So in the prior slide, I showed how the water heats up in the spring and the surface layer gets quite warm and eventually becomes too warm for juvenile salmon to pass through. So once it gets to that level that it exceeds salmon thermal thresholds, if that occurs before the salmon smolts have completed their outmigration, it can actually act as a barrier and block salmon migration out of the lakes. So every year we track our juvenile salmon that we release from the hatchery through small tags that are called pit tags that get detected at a number of sites along the Okanagan and Columbia River. And we can tell when the water temperatures get hot because fish are no longer moving and get detected at those detection sites. So it creates a thermal barrier to outmigration until the water temperatures cool back down again in the fall. And lastly, on their way out to the ocean, our smolts have to pass through 9 hydroelectric dams on the Columbia River. And on the bottom right here, you can see a picture of one of those dams. They're really quite massive structures. During low freshets, there's less spill. And that means that a greater portion of the river flow and the salmon smolts pass through the electrical turbines of those dams. And that can lead to higher mortality than if they travel over the spillways. So higher flow tends to lead to higher survival through those hydroelectric dams. Okay, so now the smolts have made it out of the Columbia River into the ocean, and after a few years, they return back to the mouth of the Columbia River near Portland and begin their migration back up the river. So that occurs typically sometime in May when our first spring Chinook and sockeye begin making their migration up the Columbia River, past all the dams, and then all the way back to the Okanagan. During drought conditions, there's usually a lower snowpack, so the flows drop more quickly early in the summer. And that lack of cold snowmelt and overall lower flows can lead to higher water temperatures early on in the summer. Usually, while the salmon are in the main stem Columbia River, water temperatures tend to be okay for sockeye early in the summer when they first start entering the lower river and begin their migration through the lower river. But once the fish pass Wells Dam, kind of right in the middle there of the map, they encounter the backwater off that dam, and that is called Wells Pool. So it's just the river is being backwatered by the dam. It's not a lake or anything like that. So in that pool is also the confluence of the Okanagan and the Columbia River. And the Okanagan River tends to be a little bit warmer than the Columbia River. And if the Okanagan River exceeds about 22 degrees water temperature, sockeye and Chinook salmon will simply stop migrating and wait in Wells Pool until the water temperatures decline, and then they start coming up the river. This phenomenon is called a thermal barrier because it blocks salmon from completing their migration. Historically, the thermal barrier is set up in about mid to late July. And by then, a large portion of the salmon run had already made it their way up into Syilx Lake and could hold safely in that deep, cold north basin of the Syilx Lake. But with the shifting climate toward warmer spring water temperatures and the earlier snowmelt, and especially during drought years with the low snowpack, hot weather, and low flows, we see the thermal barrier often setting up in early July or even late June. And that blocks a large portion of the salmon run in Wells Pool and prevents them from coming up into Syilx Lake. So unfortunately, the survival of the salmon during that holding period in Wells Pool can be highly variable, but it tends to be very poor during drought years when the water in the pool itself becomes quite warm. Water temperatures in Wells Pool can reach up to 20 or 21 degrees Celsius, and those temperatures are really quite marginal for salmon. They experience physiological stress, they deplete their energy reserves, they're much more prone to experiences diseases like columnaris and fungal infections. And heat stress also reduces egg quality and spawning success of the fish that do survive. During a particularly severe drought with really high water temperatures in 2015, only 5% of Okanagan sockeye that entered the Columbia River actually survived to the spawning grounds. So drought can really have a very devastating effect on the salmon on their migration back to the spawning grounds. Another thing I need to talk about when talking about adult migration is actually the Syilx River, because it plays a surprisingly large role in the success of our Okanagan salmon making it back to their spawning grounds. So besides summer weather, I would say that the most important factor that determines sockeye migration timing and survival from Wells Pool to Syilx Lake is actually the Syilx watershed snowpack and the timing of the snowmelt in the Syilx. The Syilx has a really high elevation headwaters, and when there's a lot of snow, it supplies very large amount of cold water into the Okanagan River mainstem well into the summer. The Syilx flows into the Okanagan River right in the middle of that map there by the little label that says Zodlo Dam. So it supplies that nice and cold water into the mainstem Okanagan River all the way down to Wells Pool. And that delays the onset of the thermal barrier that blocks salmon from coming up, and it allows a large portion of the run to migrate into Syilx Lake before the barrier sets up. So during years when the Syilx River has a high snowpack and a late snowmelt, conditions are usually good for adult salmon migrants. The Syilx River itself also provides important cold water holding habitat for Okanagan salmon. So sometimes when the salmon come up the Okanagan River and they come to the confluence with the Syilx is a few degrees cooler, and the salmon prefer that. So they sometimes choose to migrate up the Syilx River and hold there until it gets cooler again, and then they come back out and continue their migration upriver. This is called a thermal refuge. But in recent years, the Syilx has experienced very severe droughts and low stream flows, and as a result, the temperatures in the Syilx have also increased past salmon thermal thresholds. So as a result of that, those drought conditions, the thermal refuge in the Syilx has essentially been eliminated, and salmon holding there have experienced some substantial mortality events. On the bottom, you can see a chart of siwڵkw River water temperatures, and you can see in the last 5 years, especially since that drought in 2021, we've really had increasing water temperatures in the siwڵkw. Okay, now we're to the last part of the life cycle of the salmon, the spawning in the fall. So during a drought, stream flows tend to be very low, and often that can create passage barriers and shallow riffles so that the salmon have difficulty accessing their spawning grounds in the tributary streams. That's especially an issue at the confluence of rivers and creeks and lakes. For example, some of the tributaries around Okanagan Lake where they flow into the lake, or outside of the Okanagan where the Salmon River flows into siwڵkw Lake. So often there are difficulties in those areas for the salmon to even pass into those streams when the flows are really low. The photo on the right shows a sockeye passing through a very shallow riffle, and you can see most of its body sticking out, and that makes it very easy target for predation. So any bird, otter, or bear can easily walk by and just pick those fish off as they pass through the shallow riffles. So shallow water really increases the risk of predation for those fish. And just like for juveniles, less water also just tends to translate to less space. So it's just less real estate for the spawners to use. There's also direct evidence that high water temperatures and prolonged migration delays affect the fecundity and the egg quality of our salmon. So last year, we conducted an experiment, and we did that to address climate change and drought conditions and explore some ways to mitigate for those conditions. So last year, we transported over 100 sockeye from Wells Dam down on the Columbia River directly to our hatchery in Penticton. And we did that in mid-July, just when the thermal barrier was starting to set up. So we picked up the fish. On the bottom left here, you can see our hatchery truck with the fish on board crossing the border. And then we brought them to our hatchery in Penticton to be used in our broodstock program for our hatchery releases. We also collected broodstock in the Okanagan River and Oliver in October, like we normally do. So those fish had to hold in the warm water in Wells Pool last year for about 6 to 8 weeks. So they had experienced prolonged exposure to poor thermal conditions in Wells Pool. And we also took some of those as broodstock. And we then compared the egg quality and the viability of the eggs between the two sources. And the fish that we transported to our hatchery that were not exposed to the thermal barrier and that were held in cold water at the hatchery actually produced almost 700 more fry per female. So that's 44% more than those that migrated naturally and were exposed to the prolonged thermal barrier. So that shows that the effects of drought and the associated exposure to high temperatures actually carries forward through reduced egg survival and ultimately reduced fry production in the next generation of salmon. So to address some of these issues, the ONA is taking a number of stewardship actions with our member communities and other collaborators. We have participated in the regional drought response processes for over a decade now, and we're working with the province on developing a water scarcity framework for the region. And that will be used to characterize the severity of water scarcity and coordinate communication and response actions to address the issues. We also contribute local information on stream flows and fisheries concerns, and that is a way for us to achieve response actions where they're needed. We often talk directly with water purveyors, for example, to alert them of low flows or any fisheries concerns and try to work together with others to solve some of those problems. We conduct drought monitoring through our extensive network of hydrometric stations that we operate in collaboration with the Okanagan Basin Water Board. And when the flows get low, we also do field visits to streams in the region to see if there's any fish mortality or stranding, and we conduct fish salvage and relocations as needed. About 10 years ago, we partnered with the province and the Okanagan Basin Water Board to develop environmental flow needs and critical environmental flow thresholds for many of the streams in Syilx Territory. And that has helped develop a common understanding of flow targets and also of the bare minimum flows that really just need to be met to prevent catastrophic consequences. We have also supported development of fish-friendly storage releases plans for some local reservoirs. We're working on some beaver dam analog projects in the headwaters, for example, in Inkaneep Creek, it's the photo on the bottom left there, to increase natural water storage in those headwater areas. We're also working on floodplain reconnection projects through the region. In the center below, you can see a floodplain that was reconnected at the north end of Vassal Lake this past year. And most recently, the ONA on behalf of the Syilx Nation declared an actual watershed emergency to draw attention to the dire drought situation and water security threats that we're experiencing in our region, and to hopefully achieve some meaningful action to address those problems. That is the end of my presentation. Lim for listening. I'll pass it on to Eva now, and then we'll take questions after.
Hello, everybody. So thank you, Elinor. This was an amazingly informative presentation. I'm just going to share my screen now and see how this works. Oh, something happened here. Sorry about that. It's always like this when you want to do things. Where's my presentation? Here we are. Okay. Yeah, we're all good here. Let me just do from the beginning. Yeah, so we have a few little facts about water conservation. We do now, especially after Elinor's presentation, have to keep this water cool going down our creeks and rivers. But before we launched in, we have Jada here, and Jada will be explaining in Syilx word for water.
Hi, everyone. Yeah, I'm going to break down the word siwڵkŭ for you. So we can split this word up into two parts. The first part being siu, which comes from the Syilxian word that means to drink for humans. The second part, ŭlkŭ, comes from the word to drink for animals. So when we put that together, it creates siwڵkŭ, and that word means water, but it also tells us how animals and humans have equal rights to water. And it's considered sacred as the source of all life in the tempula. Of course, water is so sacred. Thank you.
Thank you, Jada. So I just wanted to quickly go over our Okanagan Lake and how it refills. It's actually, Okanagan Lake is really like a giant bathtub that only gets a little bit of water every spring, March to July. And so mostly it's snowpack. Water comes from a snowpack and a little bit from rain. So we have 1.5 meters of water that replenishes each year. So if we use more than what it's replenished, because the other one is the old lake water, we have the lake levels drop. So and currently, as of June 21st, the levels in the Okanagan Lake are 0.5 meter below the usual flow, pool. Sorry, I'm a bit nervous. Full pool, and so it's a record low. Elinor really well explained the drought versus water scarcity. I feel we are in water scarcity now because it's been 4 or 5 years since we've had drought. So that is a real imbalance between supply and demand and requires permanent change. So we all have to rethink how we use and treat water. Elinor already talked about watersheds. So we have a continental watershed that we belong to, our Columbia River. Then we have our regional watersheds, which would be Okanagan, siwڵkŭ, Nicola watersheds. And then we have our local drainage areas on a small creek level. So we should all know what is our watershed and understand its health. I come from Naramata, so I'm here at the Robinson Creek. Anyway, another things that we have to know, in addition to how important it is to know where a watershed is, it's also to understand how it functions. So we have to ask questions like, is there enough water flow throughout the year? We saw some dry creeks that Elinor just showed us. Is there enough water to meet licensed use? We are so over-licensed in the Okanagan. Are there any other water quality concerns like sediments and pollution? So all these factors influence how resilient our local water systems are. Tap water. Most of us just turn the water on and we never give it a second thought where this water is coming from. And before it reaches our homes, it travels through that map that I just showed you through different systems connected to our watershed. So understanding that journey helps us appreciate it and protect it more. But mostly our water comes from either surface waters, groundwaters, and many systems have a combination of both. So water restrictions are now fully enforced. So generally they're set very locally, hyper-locally. So they vary between one to another from areas where we live. So it's important to check with our specific water providers, what is our restriction, and we can visit municipalities, regional district websites, or check your water bill if you are unsure who supplies your water. Okanagan Basin Water Board has a very good website, Make Water Work Smart, that actually has this great one-stop hub that connects you to all current restrictions across the region. There's a draw-down menu and you can just pick your own thing. So how do we get water-wise at home? There's lots of information out there what we can do. Most indoor water use happens in laundry room, kitchen, bathrooms. So there's lots of methods of how to improve the water distribution in those areas. You can even buy laundry machines now that have a 50 to 75% less water use. There's the various low flow shower heads, toilets, so we can change all that without really changing our daily routines. So all the small changes add up. So water use in the Okanagan, the indoor domestic use is 7%, and that's pretty constant summer and winter. And then outdoor domestic use is 24%, and most of it is actually used for irrigation. So this shows how important it is to save our water in outdoor spaces. So next webinar meeting on July is going to be about water smart landscaping in the water scarce region. And we're going to be focusing on practical ways to create attractive drought resilient landscapes. We're going to look at using native plants, improving soil health, and efficient irrigation system while supporting biodiversity and respecting the land. So we hope to see some of you then. Thank you. Limlimt. Okay, there's my last slide here. Limlimt, thank you.